Thank you very much for the kind invitation to talk today. I'm really going to talk about population studies. There are lots and lots of articles every day when you open the newspaper about slowing, aging, animal studies, etc. And 3 years ago or so, there was a lot of publicity from one of the first articles based on UK Biobank, which is nearly 500,000 people who collected data. And they had this predictive questionnaire that was simply based on questions about whether you're going to die in the next 5 years. It's a simple online test, and you can go on the website to do it. Now, the questions are pretty obvious. I think if I asked any of you what you would use to predict future mortality, it's age, obviously. The older you are, yes. And sex. Women do a bit better than men. Prevalent illness, so if you've got serious illnesses, you're not going to last as long. So, look, these are things that we've known about for a long time, but they were able to devise this based on 500,000 people in the UK. I'm going to talk about a smaller cohort, but when they published all this stuff, headlines, Private Eye came out, and I don't know whether you've seen this, about the foolproof test that can predict if you will die in the next 5 years. And I think, given what's happened in the more recent past, I think this may still hold, even though this was 2015. So we're going to go back to consider demographic challenges, which I'm sure you're all very familiar with briefly, but justifying why it is so important. Then I'm going to largely present results from our cohort study, but bringing in some other population studies and some interim conclusions. These are numbers that are very familiar to all of us because we hear about them all the time, but I've just put some figures there to show you the scale of this. This is the European Union countries, which we're still in so far, age distribution 2010 and 2060, to show you just in 50 years what a big change there is going to be in the numbers of people over 65 and over 80 years, more than doubling of some of these numbers. So it's a huge impact. It's partly related to changing birth rates and also longer survival at later years. So a huge demographic change that is unprecedented in human history, but actually a great success, because the reason we're all living longer is because we're not dying in infancy from malnutrition, infectious diseases, etc., accidents. And if we look at the projected percent of the population in 100 years, more than 60 years, in selected countries, the profound change, if you have a society, Japan, that in 1950 had 7% people aged more than 60 years, and by 2050 will have nearly 1 in 2, 45% people aged over 60 years. And this is United Kingdom, which is about there. United States isn't quite such a big trend. But all countries are having this massive trend in increasing numbers of older people. And the reason this is important is because this is having a profound impact on society, all the structures that we have, which were designed for a very different age pyramid. 1950 was the year that I was born. For every person, or every 2 people aged more than 65 years, there were 24 people of working age, and then also a large proportion of children. Whereas for 2050, the projection is that for every 2 people aged more than 65 years, there will just be 4 people of working age and 1 person under 15 years. So it's a massive shift in terms of the balance of so-called working age population and older people, and that is going to have such a profound, it is having already a huge impact on society, and that's why we're having to rethink all the implications such as employment, work patterns, taxation, pensions, huge fuss in the university about pensions now, education, social structures, intergenerational relations, because my children, your children, are not having the same benefits that the baby boom generation had in terms of education, health service, etc., healthcare. But the focus of this particular talk is about health, because health, of course, is a major concern. An aging population is not a big issue if people are generally well. It's only an issue if we are not well as we get older. So maintaining optimal health throughout her life is really important, and understanding the environmental and social determinants. So The reason that aging is an issue is because as we get older, and horizontal axis on that graph, as we get older, the prevalence of disability increases. And this is something we're all very familiar with. So by the age over 85, these are different degrees of disability, 10 being the most severe, 9 to 10, we can't look after ourselves, we can't feed ourselves. But even 1 is we can't walk as fast as we used to, we can't lift as heavy weights as we used to. And so the difficulty is aging is associated with increased likelihood of disability, leading to projections about cost of care. And the reason this is also important is that at whatever age, if we are age 70, 65 now, for men and women, we can expect to live another 20 years based on current projections. Age 75, we still have another 13 to 15 years to go on average. Age 85, another 7 to 8 years for men and women. And even at age 95, we still have a couple of years to go. So the longer we live, the more likely we are to live a little bit more. And at retirement age, the so-called standard retirement age, we might expect another 2 decades of life. And the reason this is again important is because when we live these extra years of life, we want to make sure that these are high-quality lives, free of, as far as possible, of disability. And what is very marked is that using such a crude indicator of social deprivation, which is just postcode, based on your postcode, you can classify areas in the United Kingdom according to deprivation, that is percentage of owner occupancy, people on benefits, etc. And if we look at the total and healthy life expectancy in the least deprived compared to the most deprived 10% of the population in the United Kingdom, you can see there that yes, there is a slight difference in life expectancy for both men and women of about 5 years, depending on whether you are living in the least deprived or the most deprived areas. I have a colleague, Michael Marmot, who does something on the tube line, central line in London, which is that for every stop along the central line, you lose 1 or 2 years of life expectancy. There's a smart, as you go out into the more deprived areas. But what is really more marked is that not just total life expectancy, but healthy life expectancy. If you live in the least deprived 10% there for men and for women, you might expect of your 82 years or so of future life expectancy to live 12 of those with some sort of disability or some compromise, unhealthy life expectancy. But the most deprived, double that almost, 22 years lived with not in good health. For women, again, 14 years of that 80-something life expectancy, but nearly double those numbers of years lived in poor health if you live in a deprived area. So one of the most powerful determinants of life expectancy, but more importantly, healthy life expectancy, is the area you live in, a really crude measure. So this is not magic. The question is, what is there that is making such a big difference in the expectancy of healthy life years ahead? So again, the thing about my research tool is an epidemiologist. I study populations, human populations. And what I do essentially is ask people, like all of you, what you do, and then I follow you up, and then we find out who did well and who didn't, according to what happened to them. And again, this is all pretty commonsensical. Healthy life expectancy is determined by a relatively limited number of chronic conditions: cardiovascular disease, cancer, neurological conditions such as dementia, blindness, hearing loss, respiratory diseases, musculoskeletal diseases such as osteoporosis, arthritis, etc. So chronic disabling conditions contribute the most to healthy life expectancy or unhealthy life expectancy. But virtually every single condition that we know about, and I've just given you coronary heart disease as one example because the rates are really marked for women, same for men, is that if we look at the rates with age, on the right hand, the left of the international league table, and the Eastern European countries have the worst in terms of age-adjusted rates of coronary heart disease. On the right is the rate of coronary heart disease according to age. And so one of the questions is, horizontal axis age 45 to 74. As we get older, we're more likely to get heart disease. But the question is, why is it that in Japan, the rate of rise is so much lower than that in the United Kingdom or United States? And of course, again, Russia is by far the worst. So by the time they're 75, they have something like six-fold differences in your chances of getting coronary heart disease. So a Japanese person, here in this case women, age 75, has the same chance of getting heart disease as somebody 15 years younger in Russia. So that's a difference of 15 years in terms of expectancy. And there's something about different environments in which we live which have a profound impact on how quickly or how badly we age, in terms of chronic disease anyway. So international variations, time trends, migration studies, and migration time trends show that suggests that the major determinants of healthy aging are environmental, not genetic. And a large body of evidence suggests lifestyle factors. And of course, what are the obvious lifestyle factors? Diet, physical activity, smoking, pollution, etc., may have a major impact. So Linda Partridge has done a lot of biological reviews on the biological measurements of aging based on animal studies. And this is just one example. It was published in 2013. And she's just published another really nice review in Nature about a week ago, 2018, which I'll show, which is sort of emphasizing more or less the same points. But essentially, we can identify many of the cellular and biological mechanisms that are associated with aging when we study aging animals or worms or mammals, genomic instability, epigenetic alterations, etc. So there are all these mechanisms which have been identified, and there are rafts of literature on all these different hallmarks of aging. Now the question is, how do we translate these biological mechanisms into something that we can measure in free-living human populations and that may have some relevance to how we act? And this is while Linda Partridge, in her later paper, September 2018, the other one was a few years ago, has developed this further to discuss how these hallmarks of aging here that we looked at earlier might result in age-related expressions such as loss of bone, cartilage, muscle mass, gain of abdominal fat, mechanical and structural changes, lots of chronic diseases, and also discuss possible interventions and challenges such as genetics, drugs that might influence some of these processes, diet, and exercise. So that's the theory about what we can do. So these include dietary interventions, mimicking chronic dietary restriction, drugs that influence some of these axes, such as the hormone axes or growth factor axes, and some of these pathways, such as rapamycin, activating sirtuins, which are different mechanisms that have been implicated in aging. And people are exploring these, resveratrol, which is in red wine that everyone talks about, though you do have to drink something like 4 pints of red wine a day or something to get anything like the dose in mice. So I think that's, but anyway, those are theoretical potential interventions. The difficulty is a lot of these are done in laboratory animals or worms, and how does this apply to free living human populations? Because rats, for example, have very different metabolisms. And this was a really ambitious study. Everybody has been talking about caloric restriction being the mechanism by which we can prolong life. So this is a really, really ambitious study, the National Institutes of Aging study, whereby they took rhesus monkeys and for 20 years they did a trial putting them on a caloric restricted diet or usual diet, and their survival over 20 years. And they did this starting with young mice, and they also did this with old, monkeys, because monkeys being more like humans here. So this is young onset caloric restriction monkeys and old onset caloric restriction monkeys. The red are female and the blue are male, and the dotted lines are control, and caloric restriction are dotted lines. And so all I can show you, I mean, what you can see from there is females survive longer than males, which is very clear, but there was absolutely no difference in caloric restriction. This is a 20-year study. So a lot of the things that seem promising from the animal experiments, when you try them out in this 20-year trial on primates, caloric restriction made no difference whatsoever in their 20-year survival. And this sort of caused some consternation. So we're back to the drawing board, because one of the questions is, we have all these theories that we develop, but how does this pan out in real-life human populations? Because that's what we're really interested in. So I'm really going to discuss some results from our own study. And the European Prospective Investigation into Cancer and Chronic Disease was initially started because there are huge variations throughout Europe. We saw some of those earlier for heart disease, but also for cancer. And socioeconomically, it's not so different. So the question was to try and identify why different European countries had such different experiences for heart disease, cancer, and other chronic diseases. I'm really going to talk about our own study, which contributed to this 500,000 cohort, and it's the EPIC Norfolk study, which is the Norfolk-based component of the European Prospective Investigation, in which we recruited 25,000 men and women who were then aged 40 to 79 years, and this started in 1993. So 2 weeks ago, we had a 25th anniversary celebration of this study. So all these men and women have now been followed up for 25 years. And we had very detailed measurements of exposures and outcomes, so they gave us a lot of blood samples, they've been filling in regular questionnaires, having measurements over these 25 years, and being followed up for what happened to them. So the model that we have is very much based on the model we saw earlier, asking the question, what influences the rate of age-related changes in health and disability? We're interested in preventing diseases and disability. We want to prevent strokes, fractures, dementia, cancer. And we go back to say, well, why does one person get cancer and not another? Why doesn't one person fracture? Why does one person get arthritis and not another? So we measured physiological risk factors that might influence our chances of developing these chronic conditions. And we all know about cholesterol, blood pressure, etc. But we also measured things like lung function. Why does our lung function decline with age? Why does our blood pressure go up with age? Why does our control of lipids decline with age? Why does our immune function get worse as we get older? Why do our blood vessels clog up as we get older? Our clotting changes. And to go back from that, to measure these physiological risk factors in this population, but to ask, what is it that influences how everyone in this population ages? What are the exposures, the dietary factors, the lifestyle, psychosocial, physical activity, etc., and genetic? Now, you will all have heard of Elizabeth Blackburn, who won a Nobel Prize for telomeres, and she has got a thing for measurement of telomeres and predicting biological age. 400-pound test that tells you how long you'll age. We were able to do whole genome studies in the entire population, and we have now looked at all the genes for heart disease, obesity, physical activity. It's just amazing that 2007, this was one of the first whole genome studies that was just 11 years ago. And since then, we've had hundreds and hundreds of papers looking at genome association studies for all sorts of traits like heart disease, cancer, dementia, etc. But this was one of the earliest, saying a common variant in the FTO gene is associated with body mass index and predisposes to childhood obesity and adult obesity. So genes and obesity. The point I want to make here is that we measured these genes in the cohort, and what we can show is these are 27 genes that we measured, and you can score a genetic profile depending on how many of these susceptibility genes you have. The blue, the dark shaded parts, are the people who had high genetic susceptibility, a very high genetic score for obesity. And the white are the people who had a lower gene score, lower genetic susceptibility. So the first thing I want to point out is that people who had the high genetic score were, on average, fatter than the people who had the low genetic score. Both sides, you can see that. Higher mean body mass index. But the second point I want to make from here is that when we divided people into people who were generally inactive or active, the people who were active on the right-hand side had lower average BMI than the people who were inactive. So the people who were active with a high genetic score had lower body mass index compared to people who were inactive and had the low genetic score. So the point of this is that your lifestyle here, physical activity, totally overwhelmed the impact of your genetic susceptibility to obesity. So physical activity was much more powerful in predicting the magnitude of body mass index if you're active compared to inactive compared to the genetic score. So just one example, but we've done that for several other traits. One of the questions that they asked in UK Biobank was, how do you feel about that health? And one of the criticisms we always have in epidemiologic studies is that we use soft data. We just ask people questions. We have biological measures, but we ask people questions. And what is remarkable is that people assess their own health really well. At the baseline, we just asked individuals, how do you assess your own health? Do you feel good about your health? Is it excellent, good, moderate, or poor? And then we followed them up for the next 12 years. And this is the relative risk of mortality according to excellent, good, moderate, or poor. So if people self-reported poor health at baseline, and this is excluding people who already had other illnesses and is age-adjusted, etc., you can see that both for men and women, people who self-reported not feeling good about their health, poor health, had about 5 times the subsequent risk of mortality over the next 12 years, even though they had no apparent other illnesses, compared to people who had self-reported excellent health. And there's a gradient across whether it was excellent, good, moderate, or poor. So the point here is that self-reported subjective health is very strongly related to objective health, at least as measured as subsequent mortality. Strong relationship. And that association was much, much stronger than any of the blood tests that have been suggested that's supposed to predict many of these aging things, such as aging test, scientists develop blood tests, RNA. None of these have been, many of them have not been tested long term, but the ones that have been tested are not nearly as powerful as self-reported health. But we also wanted to measure other things. So we measured simple, low-cost physiological measures that are very good indicators of aging, and these are things like lung function. You just blow into a spirograph. Measure your pulse rate. A low pulse rate is a very good indicator of good health. Good lung function, good bone health, low blood glucose levels, controlling blood glucose levels, and low levels of inflammation, again measured by a very simple blood test, C-reactive protein, or your total white count. So these really simple tests that anyone can do in a GP surgery are as powerful predictors of subsequent aging and mortality as any of these newfangled, very sophisticated, developed tests. Just to give you some examples, good lung function predicts good self-reported physical function. We both asked about self-reported physical function, about things that people could do, but we also measured this objectively in terms of grip strength, etc. So we just divided people into fifths of lung function. And the people who had the best lung function here, right, the top fifth, top 20% compared to bottom 25%, this is graded across the whole relationship, were much more likely to report themselves as having good physical function. So good lung function predicts good physical quality of life function. Good lung function also predicts lower hip fracture risk. So having a good lung function followed up these people, these participants for 10 years in this case. The people who had the best lung function here, the top 25% compared to bottom 25%, had about half the subsequent risk of hip fracture for both men and women, blue men and red women, compared to people who were in the bottom 25%. So this is across the whole normal distribution. We're not talking about people who had lung disease or people who are really ill. These are healthy, normal people, and lung function was a really powerful predictor of subsequent fracture risk. We measured glycated hemoglobin, which is an indicator of control of blood glucose. And for both men and women, over the next 8 years, this was this study, that the higher your glycated hemoglobin, which is a marker of your average blood glucose in the past 3 months, the higher your subsequent mortality. Now, this is the level at which people are diagnosed as diabetes, but even below the level at which you might be construed as having clinical diabetes, across the whole gradient of blood sugar, the higher your average blood sugar levels, the higher your subsequent ill health mortality. So controlling blood sugar levels seem to be important. And this is another example of C-reactive protein and inflammatory marker. Again, I'm just sort of emphasizing for some of these markers, very similar, that the higher your C-reactive protein, the higher your mortality over the next, again, 8 years or so. And another one, this is a really simple test heel ultrasound, which you can have in any GP surgery. You just stick your heel in. It measures density of your heel bone. And that is a really powerful predictor of subsequent risk of fracture. So the better your heel ultrasound, the lower your fracture risk. There's about 5-fold difference in fracture risk between people who are bottom 10% and people who are top 30% for heel ultrasound. So really simple physiological tests that any GP can do are really powerful predictors of subsequent disabling conditions, chronic disabling conditions. But of course, what we're really interested in is, can we influence this? What are the behavioral factors that may relate to health and to physiological markers? So we measured physical activity, diet, smoking, stress, etc. And our participants were great. They gave us blood samples to measure a lot of the biomarkers of diet, and they gave us a lot of information about physical activity. More recently, they've been wearing accelerometers. But also the question is, how big is the magnitude effect of a feasible change? So, for example, smoking. Everybody knows smoking is bad for you. Nobody knows that. But we were able to actually measure the magnitude of effect in terms of lung function. We've already seen earlier that lung function is a really good predictor of both mortality, even after adjusting for smoking, and of functional health, quality of life. This is the mean lung function here in non-smokers and current smokers. And on average, throughout the whole lifespan, the whole age span, non-smokers have better average lung function than current smokers. Both groups decline with age, but on average, non-smokers have much better average lung function. And this is the prevalence of those people with poor lung function according to smoking status. So essentially, what this is really saying is that if we look at this line compared to this line, smoking is equivalent to about 10 biological years of life, of age, in terms of lung function. So if you're a smoker, your lungs are 10 years older in terms of lung function compared to a non-smoker, in terms of both function and in terms of predicting the future. Physical activity. We were interested in, not in marathon running, but in the daily activity that people do in their everyday life. This is not something that it's not about going to the gym. It's whether you cycle regularly or not, whether you climb stairs. How sedentary are you in terms of how many hours you sit watching television? And here, lung function is better. This is average lung function in men and women who climb more. So the more flights of stairs they reported climbing a day, the better the average lung function. Again, this is, again, all age adjusted. So if you climb more flights of stairs a day, your lung function is better. So daily, regular, small amounts of physical activity. The more sedentary you are in terms of television viewing hours reported a day, the worse your lung function. And this is not because sick people don't climb stairs and sick people sit and watch television the whole day, because this is across the whole normal distribution. These are, again, in healthy people, apparently, according to what they did in their everyday life. But it's not just functional, physiological measures. We also looked at how self-reported physical activity predicted subsequent mortality. And this is a 10-year follow-up. And our measures of physical activity were really moderate. You are classified as inactive if you do nothing at all, if you're a total couch potato. If you are moderately inactive, all you have to do is have a standing job, like a hairdresser, or cycle less than an hour a day. So, less than an hour a day. And moderately active was more than an hour a day of cycling or some other activity like gardening. So this free living population were not incredibly active. This was just very, very moderate differences in physical activity, just cycling a bit, half an hour every day, or just having a standing occupation was associated already here between the first two with a 20% lower mortality. And then the more active, if you had a manual labor occupation, then that was more physical activity. And also the relative risk for good physical function, and again, this is like quality of life in terms of physical performance, things that people care about, how fast can they walk, can they do things, by physical activity and smoking. And here you can see that people who are never smokers report much better quality of a good physical function compared to current smokers, and people active report much better physical activity compared to people who are inactive. And if we look at the age gradient, current smoking is equivalent to being 7 years older, or non-smoker is 7 years younger than a current smoker in terms of physical performance. And physical inactivity is equivalent to being 10 years older in terms of physical performance. So if you're physically active, you are 10 years younger in terms of your functional performance compared to somebody who isn't in chronological age. Chair stands is another test we did. And again, this is a very, you get up and down, you count how many steps, how many chair stands you can do in 10 seconds and again, this was chair stands performance in 2007 according to their self-reported physical activity 10 years ago. So it was what they were doing 10 years ago. Did that predict how well they did chair stands? And we know chair stands are a very, very good predictor of physical function and quality of life. Active compared to inactive was equivalent to 7 years younger in age in terms of performance. So this was just some attempt to put numbers on this. And this is not just our study. I'm just doing other studies have put together meta-analyses or reviews suggesting indeed that exercise, different sorts of exercise, may have a profound impact on physical function and daily living activities in frail older adults, that people who do exercise or any sort of physical activity do much better in terms of quality of life. People are really interested in cognitive function, so our participants did 8 different cognitive tests, which measure different things. But the one I'm showing you is the result for PAL, which is paired associates learning, which is developed from baboons. So you don't need education to do it. It's matching shapes and remembering shapes. And we count the number of errors. And on the left, you can see that as we get older, we make more errors. Yeah, age, we get more errors. But if we have no qualifications, educational qualifications compared to tertiary qualifications, there's a big average difference. So people who have no qualifications, again, both educated and non-educated people make more mistakes as we get older, but there is the prevalence of the number of errors are very different according to whether they had no qualifications or tertiary qualifications. And the prevalence of people scoring poorly is much lower, the percentage scoring well is much higher in people who had tertiary compared to no qualifications. So compared to no qualifications, finishing school was equivalent to 9 years younger in terms of cognitive performance, and tertiary education equivalent to 14 years younger in cognitive performance. Now, the question is, why should education, which was completed 50 or 60 years ago, have such a profound impact on cognitive function now? Is it because early education increases your brain resilience and potential, or is it because early education determines what you do lifelong, throughout life, or what is it about really early experiences? Because a lot of these were completed education up to age 20, and this is performance at age 70, 60. But it's very interesting. So if we want to prevent or delay dementia, we might really consider starting very young. Anyway, And a lot of what I'm talking about is not about prevention, or it's about postponement. It's such as heart disease. We don't want to get a heart attack at 45 or even 55, but if we have a heart attack at 95, a lot of us will be dead before then, so it doesn't matter. Or we will die of a heart attack, that's not so bad. And similarly with dementia, we do not want to get cognitive impairment at 40 or 50 or 60, but if we can postpone the onset of dementia by 5 years or 6 years, so that most people will have died of other causes before they get to the point of having dementia. So a lot of aging is postponement of onset of chronic disability. And the estimates are, for example, if we can delay the onset of dementia by just 2 years, we can reduce the prevalence of dementia by 20%. If we can delay the onset of dementia by 5 years, we can reduce the prevalence of dementia in the general population by 50%. So just simple postponement of some of these chronic conditions can have a profound impact on the number of people who are suffering with that condition. And again, this is not just our study, but there are many other studies that show that high mental activity is associated with lower risk of dementia, whether it's education, occupational activity, leisure time activity, etc. That you can see the summary is that it's protective for dementia. And these are many, many other studies that have been done in the review. And it's interesting, again, referring to early education and having more connections in your brain, that the white matter volume for different brain regions in bilinguals and monolinguals aged 70 years is very different. That if you are bilingual, you have far more connections in your brain, and also different volume. And again, is it about making more connections? The more hobbies you have, the more things that you learn, the more resilience your brain has to deterioration. And this is just to re-emphasize the projected cost by year, that if we have an intervention that delays onset by 2 years and by 5 years, that we have substantial impact on the population in terms of savings, in terms of dementia support. And the good news is that actually, from the surveys both done in the United States and in United Kingdom, that the prevalence of dementia in England and in America over time, in 2 time periods, seems to be declining. So actually, even though numbers of people with dementia are increasing because there are more old people who are more at risk, the actual age-related rates of dementia are actually declining. So people are actually better now, or having less risk of dementia now, at a particular age than they were 10 years ago. So something good is happening. But there are more old people, so that's why we're seeing a rise in dementia cases. So I've talked a bit about physical activity, diet. We measured blood vitamin C, not because we think vitamin C is good, but because it's a very good biological marker of fruit and vegetables, because humans don't make it. So the amount of blood vitamin C you have is a good indicator of your fruit and vegetable intake. And the points I just want to make is that whether we look at lung function, that as we get older, on the left, our clotting goes up, that purple line. Our lung function declines, we saw that earlier, and our blood glucose gets worse as we get older. This is things that seem to happen with age. But on the right-hand side, if we look at the fifths of blood vitamin C, that people who have the highest fifth of blood vitamin C, people who eat the most fruit and vegetables, have better lung function, they have lower blood glucose, and they have better, that's lower blood glucose, and they have better inflammation, less inflammation. So high fruit and vegetable intake seems to improve some of these biological measures of aging, and it also seems to relate to future mortality from cardiovascular disease. These are fifths of plasma vitamin C, and the higher the vitamin C there, the top 20% compared to bottom 20%, about a halving of subsequent mortality. Intake of about 50 grams, 1 serving of fruit and vegetables a day, associated with 20% future mortality over the next 10 years or so. Maybe I can talk about dietary fat later. I think I'm running out of time. But the point is that, the point I made is that there's a lot of controversy about fat, and it's not as simple as all saturated fats are bad. We were able to measure even chain fatty acids and odd chain saturated fatty acids. The even chains comes from some saturated fatty acids. The odd chains come from dairy because they're 15 and 17, and the main sources of those saturated fatty acids are ruminant animals. And this is a European study, and we found the same in our cohort and replicated in Europe. This is for diabetes as an endpoint, that high intake of even chain saturated fatty acids is associated with increased risk of diabetes here, but odd chain fatty acids is associated with protection. So high intake of dairy products, and when we looked at the food, it was fermented dairy products, so it's yogurt and cheese, seems to be highly protective for diabetes, and we found the same thing for heart disease. So one of the things about measuring diet better is it's not just some foods are bad. We have to be more fine-tuned about the biochemical profile, because odd chain and even chain saturated fatty acids have completely different biological profiles, mechanisms and actions. So saturated fatty acids are not all the same, and we need careful interpretation. We found the same thing for heart disease. So the food source of saturated fat matters, and the food matrix includes all the other things that we find in foods. So we're moving towards saying nutrients are bad, this nutrient is bad, this nutrient is good, to saying what are the foods that they come in, and also what replaces fat. We've always said in the past that you'll still see this controversy about saturated fat, that if we replace saturated fat with polyunsaturated fats, you will see that there was a protection. This is done by Mozaffarian from the Harvard group. Protection in terms of heart disease. If we replace saturated fat with carbohydrate, there is no benefit. So it's not just cutting out one thing, it's what do you replace it with? And again, this comes back to dietary patterns, not just single nutrients being bad. And so the movement is much less to nutrients, but to food patterns. And there was a lot of publicity about this, which is the Mediterranean diet, because one of the puzzles about the Mediterranean diet is that it's actually quite high in fat. And yet the Spanish and the Italians on the Mediterranean diet have lower heart disease than the Northern Europe. And so this was a trial, 5 years, where individuals were randomized into 3 groups. One was the American Heart Association low-fat diet. One group was the Mediterranean diet, where they had 1 liter of extra virgin olive oil a week, which is a lot of olive oil. And one was a Mediterranean diet where they were asked to eat 30 grams of nuts a day. And here, you can see this is a control diet, low-fat diet. This is the Mediterranean diet of nuts or olive oil, both of which showed a 30% lower cardiovascular risk. So again, the dietary recommendations are becoming far more nuanced in terms of type of fat, much more and what you replace it with. And this is a sort of joke BMJ Christmas article, but based on a lot of the previous research. A combined meal of these 7 foods which have been associated might be potentially reducing CVD by more than 75% and increase life expectancy by 5 years. So wine, fish, dark chocolate, fruit, vegetables, almonds, and garlic. We actually looked again at 4 lifestyles. And again, this is the free living population. So they weren't, we didn't ask them to do anything. We just measured what they did. And you count 1 for each positive health behavior. 1 if you're a non-smoker, 1 if you're a moderate alcohol drinker, not a non-drinker, not very heavy drinker. 1 if you're not a total couch potato, anything beyond nothing activity. And 1 if you have blood vitamin C indicating 5 servings of fruit and vegetables a day. And 25% of the Norfolk cohort, free living cohort, were able to have 4 health behaviors. So you can score 1 to 4 on these, 0 to 4 on these 4 health behaviors. And these are the survival curves here for these 4 health behaviors. This is if you had no health, this is over 14 years in this particular follow-up. If you have no health behaviors, that's the survival curve. 3, 2, 1, no, sorry, 0, 1, 2, 3, and 4. If you have, these are the survival curves if you have 4 health behaviors. These are the relative risks of all-cause cardiovascular disease and cancer. So if you have 4 health behaviors compared to none of them, that's about a 4 to 5-fold difference in your subsequent mortality over the next 14 years or so, equivalent to 14 years difference in life expectancy from very simple behaviors that most people were able to practice in their everyday life. 25% of the population doing it without any effort whatsoever. So very, very small changes, differences in health behaviors, and they're totally feasible and easy to do, are associated with substantial observed differences in health. So the good news is that actually, as with dementia, the age-specific disability in England and Wales is declining with age in different surveys. In 1976, this was the prevalence of people who couldn't do 4 functions: feed themselves, look after themselves. This is the prevalence at the same age in 1991. So at age 85 in 1991, there were only 20% of 80-year-olds who were severely disabled compared to 45% in 1976. So we're getting healthier as a population. So that's good news. If we project these numbers to the next 2 decades, that's the difference, depending on these prevalences, of having 1 million people who are disabled and unable to care for themselves, and 3.5 million people in the population who are disabled and unable to care for themselves. Based on these are real-life estimates. So we are already seeing a massive change in the health of the population, and the question is, what more can we do to carry on these improvements? And the projected scenarios of shifting, just postponing disability by 1 or 2 or 3 years, can have a profound impact on the projected numbers of people in the European Union who are going to be disabled, between a decline and an increase of 20 million or so. So very, very small changes in the prevalence or the amount of disability or postponement can have a huge impact on the population in the future. So really, to summarize, and this is a very old Time magazine, how to live to be 100, that's what Americans aspire to, but most British people would say, I want not to regret living to 100. So we know that aging trajectories are modifiable. A very small change can make a big difference, and it's never too early or too late to change or make a difference. It's really exciting now for population studies because the technological advances we've heard of mean that we can measure things much better in a lot of people, genes, wearable technology to measure the physical activity better, measure pollution, the environment, and that we can understand much better what we can do to influence health. And I'd just like to finish by thanking all the participants who filled in endless questionnaires, given endless blood samples, the staff in EPIC Norfolk, and the people who funded the study. Thank you very much.
Thank you. That was absolutely wonderful. And we hear so much in the news about this or that is good for you or bad for you. To see it so beautifully, quantitatively presented is a great relief. And I'm okay with cheese and wine. Sausages, I think. Yes, questions, the normal routine, if I like to look for you on. Let you speak, yes, gentlemen there.
With the information about the people with less cognitive ability in the start having less in the future, could it be that education isn't what makes them different, it's just the fact that they get into education if they have a higher cognitive ability in the first place?
No, the interesting thing about this particular generation is that there wasn't such a big, we've looked at social class, etc., but a lot of people didn't finish education because that was how it was in that stage, in tertiary education. I mean, it was class-related. But, I mean, it's a bit like the cohorts of people in America, many of whom are CEOs, but who never finished school. So there is this thing about, is it reverse, as the brighter people who got into education and therefore have more cognitive reserve to start with. We can never completely discount that. But in this cohort, there are many other reasons why people didn't go to tertiary. This is a cohort where a lot of people didn't go into tertiary education.
You made a point about at least you suggested that bilingual people and possibly trilingual people, this sets up more networks in the brain.
Yeah.
Is there any evidence that playing a musical instrument to even a moderate level has a similar effect?
There is a lot of work on that. It's harder to, we're looking at that in our cohort as well. The things that seem to have, my colleague Khaw is the one who's a real expert on cognition, but it seems to be that activities that require integration of both your mind and your body are the ones that have the most impact. So that's probably why learning a language is important because of cognitive research. Cognitive resilience. But musical instruments are thought, learning a musical instrument is thought to be really, really good because you have to both coordinate your brain, your mental function, and your physical function. And that's another reason that dancing is also thought to be good because you have to think as well as move. So activities that combine both are thought to be the best. But from the meta-analyses of previous studies, yeah. Any leisure time or occupational activity is beneficial. Yeah, additional.
And then, gentlemen, to your right. Just where you are now, come on the right. Yeah.
Okay. Hi. So it's often said that the breakdown for kind of the health just the way longevity and health outcomes are measured and quantified can be broken down to like 70% lifestyle and 30% genes. And I was wondering how exactly that's quantified. Yeah.
I think a lot of the original work was based on twin studies and how far identical twins differed compared to non-identical twins. But I think it's an impossible question to answer because, as you saw, a lot of that was the interaction between genes and environment for the physical activity. And we're seeing a lot of that, too, with lots of other genetic susceptibility and lifestyle. So it's not one or the other. It's the interaction of one with another. You can put any number. It could be 100%. For identical twins, any difference between them is 100%. Or it could be 0. You can put any number on it. It depends on how much your environment is different compared to how much your genes are different. If your genes are identical, then 100% is environment. Right?
Hello. Have you looked at the biological profiles of those who are a little older, say 90 plus? I certainly feel much better than I did 30 years ago now.
No, we haven't. That's great. It's great to hear. But No, but we have the potential now because we have a substantial proportion of, substantial numbers. The oldest person in our cohort is now 102. And some of them are still performing cognitively brilliantly.
Hello. Thank you for such an interesting talk. I'm a GP registrar, so I'm sort of guilty of some of this. I'm specifically interested in the odd versus even saturated fatty acids. Yeah. Do you think that sort of that perhaps surprising outcome of dairy, how related is that to fermented foods as a category? Do they stand alone as a category? It's interesting to me.
It's very, very hard to tell.
Okay.
Because it's a mark of dairy, because humans can't produce odd-chain fatty acids. So the amount of odd-chain fatty acids you have in your blood must completely be external sources. So the question is, how much of that is fermented and how much is not? So you can only do that from questionnaires. Now, from the European study, it seems to be largely in the fermented component, the cheese and the yogurt. But other studies, and there was the Welsh study, Caerphilly study, like 30 years ago, which reported that men who drank milk did better for heart disease. And there was such controversy at the time that the MRC unit was closed down for being, bad. But actually, I think the thing is still out on dairy. And I never used to be bothered much about sources of milk, but I think there's a lot of evidence now that, for example, grass-fed cows have completely different fatty acid profiles from cows that are fed on corn. And a lot of the studies on dairy come from America, where the cows are fed completely different feeds from grass-fed cows in in Kenya, because we did a few studies in Kenya where the Maasai just eat milk and meat, and they have no high, their cholesterol is low and blood pressures are low. But that's because their cows are sort of eating scrub, and they're not eating corn. So I think the way we treat our animal foods has a big impact.
The NHS estimates that as the population grows older,
Yes.
the NHS will be under great stress. Now, surely the reverse is the truth, is it not? Because if one discounts the first 20 years of one's life as being useless, the remainder and the jobs are becoming less stressful physically, one can be useful much longer than previously.
Yes. And that's why we're being forced to rethink the whole of society, and what happens in society, because while it's not possible to carry on with a heavy labor job for the rest of your life, and most people wouldn't want to do that, there are many other things, and this audience is a sort of example of people who are incredibly active and contributing in later life. And I think we have to think about how we re-engineer society to make best use of the skills of older people. In Singapore, where they have the same population change, because they had this huge birth control thing about 40 years ago, they are having a big demographic difference. And their government, which is very centrally controlled, says work till you drop. I'm not sure that's something that we want to do, but that's what they're saying. We have, that older people now have to work, much longer. And there may be good things as well as bad things about that. Yeah. But the pension age was set, I think, at a time when life expectancy was much, much lower.
May I ask a second?
So we need to find out, we need to, which is what's happening now, find ways of identifying how we can best make use of skills of older people in appropriate ways.
You haven't said very much about alcohol, really.
Yes?
Alcohol consumption, can you...
There's been a lot of studies now that, every day, last week, another report saying there's no good thing about alcohol, it's bad for you. The evidence that we have is that it is protective for heart disease. Now, of course, at the top end, if you're drinking, 3 bottles a day, then of course it's bad for you. But the big debate is around moderate alcohol drinking of about 2 to 3 units of alcohol a day. And the evidence for that is not that it's bad. I mean, there is this thing about cancer, but the risk of breast cancer in women, it doesn't rise very steeply with, the risk-benefit balance is different. But of course, the population that we have, most people don't drink, huge amounts of alcohol. If you're drinking within the range of 21 to 28 units a week, the recommendation is 15. That's why we use 14 units a week.
How about the reliability of people's estimates of how much alcohol they can
Well,
drink?
I think the evidence is that the nadir of the U is about 2 to 3 units a day. But not everyone will agree with me, and some people will say I'm recommending poison. Okay.
Yes.
I think the good news is drinking in older people is certainly beneficial because older people are most likely to suffer from cardiovascular disease, and I think alcohol is protective for cardiovascular disease. It's bad for 20-year-old men because that's when they all die of accidents and violence and fighting, and that's so age-appropriate recommendations perhaps are important.
The news is getting better and better.
Yes, thank you very much. It's wonderful to get all this good, solid evidence. But when we leave here, can we look it up somewhere? Is there somewhere where we can see a guide to the healthiest things to keep us younger?
There are lots of books and recommendations. This is going to go on the website, but I've referenced the papers. But if you want an article. The Linda Partridge thing in Nature, which was published a week ago, is a very good summary. It's got a lot more biology in it, which I haven't really talked very much about. But she does summarize the sort of, she does make references to the kind of lifestyles.
There are 3 on that, a young gentleman there. Gentleman with the name.
So it's Linda Partridge in Nature, the review. I think it's September 18th or something. Yes.
very much, Doctor, for the talk. I was wondering if you have studied the association between meaningful social relationships like social network, positive engagement in society, and better health outcomes in relation to better cognition. Or
yes, there is a relation. We published on a sense of coherence, which is how the three things you ask about: how good do you feel your life is, how valuable, what networks you have, and that's additionally protective on top, the psychological, psychosocial, on top of all the physical, lifestyle, other things. I just didn't have time to talk about it. Yeah, social engagement is important. So this sort of thing is really good.
Quick question. Thank you for your talk, but I was wondering, with trend studies, how much to an extent was the chromosomes proven to show like the lengths
of telomeres
to be responsible for life expectancy for like, identical twin studies? And then a sort of follow-up question: with women living longer, on average, is this mainly dependent on the different build-up of chromosomes?
150 years ago, women and men had almost the same life expectancy. And men used to die young in warfare, and women used to die young in reproductive life, childbirth. And then the childbirth thing has improved, but men still die of violent death. So that's a big difference. The big female and male gap in life expectancy is around the 20s, when men die violent death and women no longer have the high reproductive mortality. The second big gap is for cardiovascular disease. Men have far more coronary heart disease than women, and people have spent decades trying to identify why men have more coronary heart disease than women, and we still don't know. It's not hormones, because all the trials of hormone replacement therapy or estrogens have not shown any benefit for that. And we still don't know. So that's a big, big issue. And there are stacks and stacks of papers. People have spent their whole lifetime looking at that. So the main difference in life expectancy in later life is coronary heart disease. In early life, it's violent death.
I was going to ask, thank you for the interesting talk. I was going to ask about social capital, which I think was asked earlier, and the importance of that. And also mental health. You mentioned stress, depression and anxiety, and men.
Yes. And men?
Well, because, do women maybe express themselves more, or is there some sort of way of self-regulating stress and anxiety and depression, which maybe is inbuilt in women because we talk?
Yeah.
We express feelings.
Yes. There are very good brain studies of women and men talking, and when you talk about something sad, the whole brain of a woman lights up and the men's little bit goes up. But I'm just being, those are different studies that my colleagues have done. We have looked at it. I haven't really looked at the sex difference in any detail. We have the data, so if anyone wants to look at the data, they're welcome to. One of my PhD students did look at generalized anxiety disorder and found that was predictive in women, but not in men, surprisingly enough, of future hospitalization. So, but maybe it's because women report generalized anxiety. They report their psychological symptoms more than men. So maybe men don't, it doesn't predict in men because they don't report their symptoms the same way. I don't know. I don't know, because for a lot of these psychological things, we can only rely on self-report. And if they report differently, there's nothing we can do about it.
I think the answer's fairly clear. My wife says I don't have any emotions, so put that back to everybody else. Sir.
Thank you. Wonderful talk. Have you, or do you know of anyone who has done some studies relating age of retirement with life expectancy?
There was a study, again done in BMJ, this was like decades ago, suggesting that GPs who retired late, I can't remember, I don't even remember the result now. I think GPs who retired, do you remember the result? It was I should remember it. Looking at different ages of retirement of GPs, and reporting that the GPs who retired early, I think, died earlier than the GPs who retired late, but I'm not sure I've got it the right way around now. It was a long time ago, so in my memory. But people, Yeah, it might be that. Yeah, so there are lots of confounding factors in retirement. But the people who do really well are people who carry on work, who seem to have activities after retirement. But whether paid employment is a different issue. We haven't looked at that specifically, and I haven't looked at that specifically.
I'm hoping 67 is the optimum retirement age. I'm behind the clock, so I'd like to sweep round and collect a few questions, please, if I've missed anybody, and then I'll have to take them all together. So, who have I missed? Down at the front here, 2 quick questions, and then behind you.
Hello. Thank you very much. The link between dementia and education, I wonder how much you can tease out the difference between poverty and education, because there is such a large link in terms of all kinds of different age-related death to do with poverty. Can you actually tease out that
It's very
link?
difficult. I mean, you can measure a lot of things and try and adjust for them. So other studies, not ours, have adjusted for childhood poverty, like, do you have a lavatory in your house and all that sort of stuff. Mm-hmm. But you can never adjust completely for it. So this is the same question as before, is it reverse causality?
That's right. That's what made me ask it, was thought that was close to the question.
Yeah. Is it a proxy for poverty or poor circumstances?
Right.
The ability, what you see in education. The only thing is, a lot of this is replicability. So in whatever population you do this, you find the same association. So the amount of education, even after adjusting for income, social class, etc., seems to hold very strongly.
Right. Thank you. That's it.
Can I ask you to chain a few questions and then ask Katie to answer them together? So, gentleman beside you there.
Not for me, no. It was for me.
Asking for a friend, I understand. Like when I go to the off license at the back there.
Okay, excellent presentation. That's a 2 point. That's me. The 2 point. 1 point is regarding to the psychology effect. It means the excellent health self-report, the outside pro-condition, always a big difference in life expectation. Second, about the geography effect, the country-to-country difference. Russia and Japan, such big difference. Yeah. You can transform Russia to Japan lifestyle, Putin will thank you. So I suggest comment on these 2 points. One psychology, another country-to-country difference.
So I'm not...
I'll go through and collect
Yeah.
Given the strength of the relationship between how people feel and how long they're going to live, what difference is the medical profession making?
Well, you know that the mortality rate always goes down when doctors go on strike. So, I don't know.